Hello and welcome back to my channel. This is Walter here, taking you through Pure Mathematics 1 papers. Today we have the May-June 2020 paper. We have paper 13 here. So let's get started. Question number 1. Find the set of values of m for which the line with the equation y is equal to mx plus 1 and the curve with the equation y is equal to 3x squared plus 2x plus 4 intersect at two distinct points. So right here, we're talking about intersection of a curve and a line. And if a curve and a line intersect at two distinct points, it means that the discriminant b squared minus 4ac should be greater than 0. So here I'll combine the two equations. So I'll take the equation of the curve, which is y is equal to 3x squared plus 2x plus 4, and I'll equate it to the equation of the line where y is also subject, so they should be equal. So that's mx plus 1. I'm gonna take everything to one side, so I have 3x squared here plus 2x, that's already on the left side, and I'll subtract mx from both sides, so that's minus mx. And that's plus 4, which is already here, but I'll subtract 1 from both sides, so that will be minus 1 is equal to 0. I'll just simplify, so that's 3x squared plus, here x is common, so I'll factor it out. So I'll have 2 minus m inside the bracket, and that's plus 4 minus 1 is 3, and that's all equal to 0. Now for the discriminant, a is the coefficient of x squared, so a is 3. B is the coefficient of x, so b is 2 minus m. And c is the constant, so c is equal to 3. So when I perform the discriminant, I'll be saying b squared, which is 2 minus m squared, minus 4 of 3 of 3. And we say the discriminant should be greater than 0. Expanding, I have 2 squared, that's 4, minus 2 times the product of this 2. So that will be 2 times minus 2m, which is minus 4m. And then that's plus the square of minus m, that's m squared. And then that's minus 4 times 3 times 3 is 36, and it's all greater than 0. Rearranging, I'll be having m squared minus 4m, and 4 minus 36 is minus 32, and that's all greater than 0. I can factorize this, and here, since we have m squared here, I'll put m, and look for the factors of minus 32, whose sum comes out as minus 4. So that should be minus 8 and plus 4. So this is what we have. Now for the critical values, we can say m minus 8 bracket m plus 4 is equal to 0, where either m minus 8 is the one that's equal to 0, or m plus 4 is the one that's equal to 0. So m comes out as an 8 and m comes out as minus 4. So we now have two critical values, and since we want to find the set of values of m, we can have a little sketch of the parabola here. So this is like the m-axis, and the lower value is minus 4, and the higher value here is 8. And we know that this graph is positive above the m-axis and negative below the m-axis. So we want to find the set of values for which m squared minus 4m minus 32 is greater than 0. And greater than 0 means positive. So this graph here is positive for values of m that are less than minus 4. You see how they are all above the x-axis, greater. And all values of m that are greater than 8. Again, they are above the axis, that's positive. So we can write down the solution that m is less than minus 4 and m is greater than 8. And these are the two solutions as required here. So that's how we do it with question number 1. Let's scroll down to question number 2. Question 2. The equation of a curve is such that dy by dx is equal to 3x to the half minus 3x to the power minus half. It is given that the point 4, 7 lies on the curve. Find the equation of the curve. So I'll write down the differential equation. Dy by dx is equal to 3x to the power of a half minus 3x to the power of minus a half. And here I'll integrate both sides. So integrating the left side, we will get y. And on the right side, integrating 3x to the power of a half, we'll be having 3x to the power of a half plus 1. That's 3 over 2. And it's all divided by 3 over 2. And then that's minus 3x to the power of minus a half plus 1. That's a half. And it's all divided by a half. And then that's plus c. I can simplify. So y is equal to 3 divided by 3 over 2 gives us 2. So that's 2x to the power of 3 over 2. And then that's minus, and 3 divided by a half, that will give us 6. So 6x to the power of a half. And then that's plus c. Now that we have the general solution of the equation of the curve, we now want to find the particular solution where we'll be substituting 4, 7 into this equation of the curve. So it means for x, I'll put in 4, and for y, I'll put in 7. So this is going to come out as 7 is equal to 2 of 4 to the power of 3 over 2 minus 6 of 4 to the power of a half. That's plus c. So we can simplify. So that 7 is equal to 2 times square root of 4 is 2, and 2 cubed is 8, minus 6 times square root of 4, that's 2. So that's 6 of 2, then plus c. So that 7 is equal to 16 minus 12 plus c. And 16 minus 12 is 4, so that's 4 plus c. And I think you can see that here, c should come out as 7 minus 4, which is 3. Which therefore means the equation of the curve should come out as y is equal to 2x to the power of 3 over 2 minus 6x to the power of a half plus 3. So this here is the equation of the curve. And that's it for question number 2. Let's scroll down to question number 3. In each of parts A, B, and C, the graph shown with solid lines has equation y is equal to f of x. The graph shown with broken lines is a transformation of y is equal to f of x. So on A, they say, state in terms of f the equation of the graph shown with broken lines. Now you can notice that the graph with broken lines is a reflection of the bold graph, and the mirror line is the y-axis. So for a reflection in the y-axis, we would write the equation of the reflection as y is equal to f of minus x. And that's the answer here for part A. Then for part B, state in terms of f the equation of the graph shown with broken lines. Now if you look here, you can notice that the graph y is equal to f of x has been stretched to produce the graph with broken lines. And what is the stretch factor? Well, if you look at a point and its image, like if you look at this point, the y coordinate is 2 and its image here has the y coordinate 4, which means there's a factor of 2 here that is mapping object to image. So you can notice that that's what is happening. Even if you look at this point here and this point here, it's again a factor of 2. If we multiply the y coordinate by 2, we get the image. So the factor appears to be 2. You can also notice that the x values are not changing. So x value remains 1, x value here remains 2. So it means that the x-axis is invariant. So if it is a stretch by factor 2, we can write that as y is equal to 2 of f of x. And that's the answer right here. Then to part C, again it says, state in terms of f the equation of the graph shown with broken lines. So here we can see that the graph y is equal to f of x is being translated to the graph with broken lines. It's actually moving in a straight line but maintaining its original dimensions. So it shows that it's a combination of translations. So I'll try to move from this point to its image, which is here. In the x-axis, I'll move 1, 2, 3, 4. So that's -4 in the x-axis. And then I'll go down 1, 2, and 3, which is -3 in the y. So this is our translation vector. And how do we write that in terms of f? That would be y is equal to f of x plus 4. That's for the translation in the x direction. And that's -3. That's for the translation going down by 3 units in the negative y direction. So this becomes the equation of the graph in terms of f. Question number 4. Expand 1 plus a to the power 5 in ascending powers of a up to and including the term in a cubed. So for this one, I'll make use of this binomial expansion of 1 plus a to the power of n from the data booklet. So I'll say, since we have 1 plus a to the power of 5, so it's 1 plus a to the power of n is equal to 1 plus nx going all the way. So I'll say 1 plus a to the power of 5 is equal to 1 plus nx. So that would be 5 of a plus n of n minus 1. So that would be 5, 4 over 2 factorial of a squared. That's x squared. Then that's plus n of n minus 1 of n minus 2. So that's 5, 4, 3 over 3 factorial of x cubed. In this case, x is a. So that will be a cubed. So I can now just simplify this. So that's 1 plus 5a plus 5 times 4 over 2 factorial. That's the same as 5 times 4 over 2 times 1. That's 2 factorial. So I can divide 2 into 4. So 5 times 2, that's 10. So I'll be having here 10a squared. Then that's plus 543 over 3 factorial. That's 5 times 4 times 3 over 3 factorial is 3 times 2 times 1. So 3 into 3, that's 1. 2 into 4, that's 2. So 5 times 2, that's 10. So that's 10a cubed. So this is what we have eventually. That's the answer to part A. Let's go on to part B. Hence expand 1 plus x squared in brackets to the power of 5 in ascending powers of x up to and including the term in x cubed, simplifying your answer. Okay, so here they're saying hence, which means that we're going to use what we have already come out with from part A. On part A, we expanded 1 plus a to the power of 5 here. So that was 1 plus a to the power of 5, and it came out to be this. So we want to make use of the same expansion, because if you can notice, when we have 1 plus x squared to the power of 5, apparently you can see that a has been replaced by x plus x squared, but the binomial expansion is the same. So I'm going to substitute x plus x squared for a in this expansion. So this is going to give me 1 plus 5a, which is 5 of x plus x squared. And that's plus 10a squared, which is 10 of x plus x squared squared. And then that's plus 10a cubed, that's 10 of x plus x squared cubed. So we're going to simplify this, and remember, we want the powers up to and including the term in x cubed. So let's simplify. So this will give us 1 plus 5 times x, that's 5x, 5 times x squared, that's 5x squared. Then that's plus 10 of, and then we expand x plus x squared squared. So that's x squared plus 2 times the product of this 2, so that will give us 2x cubed. And then that's plus x to the power of 4 as x power 4. Then that's plus 10 of, and then here we want to expand x plus x squared cubed, which I can say is the same as x. This part is x plus x squared of x plus x squared squared. That's the same as x plus x squared cubed. So I can do it this way. I can say that's 10 of x plus x squared bracket, and x plus x squared squared is what we've already obtained here, which is x squared plus 2x cubed plus x power of 4. So this is what we have. So here I'm just going to collect the terms up to and including the term in x cubed. So let's do that. So 1 plus 5x plus 5x squared are all okay. Then that's plus 10 times x squared, that's 10x squared. Then 10 times 2x cubed, that's 20x cubed. But I will not take 10 times x power 4 since it's greater than x cubed. So that's plus, and here I have the 10 already. Then x is going to multiply this bracket. So x will multiply x squared to give us x cubed. But x, if it multiplies the other terms, it will get something that is higher than x cubed. So we'll leave those results out. And x squared, if it multiplies all these terms here, it will give us also something that's greater than x cubed. So we'll only take x cubed here. So we can now simplify this to 1 plus the terms in x, we only have 5x. Then the terms in x squared, we have 5x squared and 10x squared. So that gives us 15x squared. And the terms in x cubed, we have 20x cubed and 10x cubed, and that's 30x cubed. So these are the only terms in ascending powers of x up to and including the term in x cubed. That's our answer right here. Question number 5. The diagram shows a cord going around a pulley and a pin. The pulley is modeled as a circle with center O and radius 5 centimeters. The thickness of the cord and the size of the pin P can be neglected. The pin is situated 13 centimeters vertically below O. Points A and B are on the circumference of the circle such that AP and BP are tangents to the circle. The chord passes over the major arc AB of the circle and under the pin such that the chord is taut. Calculate the length of the chord. Now I hope you have understood the question. Now to find the length of the chord, we will do that in parts. So we can start by looking for the length of the part AP, which is also similar to BP. So these are the two parts that we'll start with. And after we're done with those, then we can then look for the length of this major arc. And we will now have the total length of the chord. Now for the part AP, of which we know that AP is equal to BP, we can use Pythagoras. So by Pythagoras, we can say AP squared is equal to 13 squared, which is the hypotenuse, minus 5 squared. And this gives us 169 minus 5 squared, that's 25. And this is 144, which therefore means that AP is equal to the square root of 144. So we get AP coming out as 12. So we now know that AP is 12 and also BP is also equal to 12. And that's in centimeters. Okay, so for the chord, we now have AP and we now have BP. And what's left for us to find is AB, the major arc. Now to find the major arc, I will start by looking for the length of the minor arc, which means to find the length of the minor arc, I will need to know what this angle, whole angle is. Now I'll start with this angle here, which is angle A or P. And I'm going to use the trig ratio cos to find this angle. So I'm saying here, cos of A or P, cosine is adjacent of hypotenuse. So for this right angle triangle, the adjacent side is 5 and the hypotenuse is 13. So cos A or P is 5 over 13, which means the angle A or P should be arc cos of 5 over 13. So we can type that in. So I'll have the mod in radians here. So that's shift mod, then radians, that's 4. So 4. So we're now in radians. So that's shift cos 5 over 13. And this gives us 1.176. So that's 1.176. So that's angle A or P. Which means that now that we know what angle A or P is, the value of the whole angle, which is A or B, should be twice that angle, since they are both equal. So that would be A or B is 2 times 1.176. So the angle here will be times 2. And that's 2.352. So 2.352. So this is what we have for the angle A or B. So now that we have the angle A or B, we can work out the length of the arc, minor arc, AB. Remember, length of arc is calculated as r theta when theta is in radians. So let's do that. So minor arc AB is r theta, and the radius, what's the radius by the way? The radius of the circle is 5. So we use 5 here. So that's 5 times theta. We had obtained theta to be 2.352. So times 2.352. So we're just multiplying this. So we already have this on the screen. So that's times 5. And we get 11.76. So 11.76. So that's the length of the minor arc. Right, so to find the length of the major arc, we can subtract the length of the minor arc from the length of the whole circumference of the circle, which is obtained by 2 pi r. So when we're now saying major arc, AB will be 2 pi r, which is 5, minus 11.76. So let's type that in. 2 pi times 5, that's 10 pi. So we have here 10 pi minus 11.76. And that's 19.655. So let's just say 19.7. So that's 19.7 right here. So that's the length of the major arc. So here we can now find the length of the whole chord. We're now saying the length of chord is going to be equal to the length of AP, the length of BP, and the length of the major arc. So that's arc AB. So this is what we're going to use for the total length of the chord. So we're saying here, length of chord is equal to this. So AP and BP, we obtain them as 12. So that's 12 plus 12. And arc AB is 19.7. So we're just adding the 3. So here we're just saying that's plus 12 plus 12, that's 24. And that's 43.7. And that's in centimeters. And this here is the answer. Question number 6. A point P is moving along a curve in such a way that the x-coordinate of P is increasing at a constant rate of 2 units per minute. The equation of the curve is y is equal to 5x minus 1 all to the power of a half. So on A, find the rate at which the y-coordinate is increasing when x is equal to 1. Now let's start with the information that we have been given. The x-coordinate of P is increasing at a rate of 2 units per minute. So that's dx by dt is going to be 2. Then we also have the equation of the curve. That's y is equal to 5x minus 1 all to the power of a half. So this is the information we have. Now, this is a rates of change type of question, and we will also have need of the derivative of y in terms of x. So here I'll find dy by dx. So I'll bring down the half, then the 5 here from 5x minus 1 derivative, then 5x minus 1 to the power of a half minus 1, which is minus a half. This can be simplified to, at the top I'll be having 5, and at the bottom I'll be having 2 bracket 5x minus 1 to the power of a half. So this is dy by dx. Now here for part A, where they want us to find the rate at which the y-coordinate is increasing, we're saying that's dy by dt. And that's equal to dy by dx multiplied by dx by dt. So the dx's seem to cancel. So we've obtained dy by dx as 5 over 2 of 5x minus 1 to the power of a half. And we're going to multiply that by dx by dt, which is 2. But you see, they say here when x is equal to 1. So we know that x is equal to 1, and therefore the dy by dt should come out as 5 over, and that's 2, and 5 times 1 is 5, 5 minus 1, that's 4, and 4 to the power of a half is like square root of 4, so we get 2 here, and that's multiplied by 2. So this can just simplify to 5 over 4 times 2, and dividing 2 into 4, we get the final result as 5 over 2. So dy by dt is equal to 5 over 2. And that's the answer right here. They wanted us to find the rate at which the y-coordinate is increasing. So that's 5 over 2 centimeters per second. That's the result here. Let's scroll down to part B. On part B, find the value of x when the y-coordinate is increasing at 5/8 units per minute. So here we're going to need the chain rule for the rate of increase of x. So that's dx by dt. And the chain rule will go dx by dy multiplied by dy by dt. Now, dx by dy is like the inverse or reciprocal of dy by dx, of which we had obtained dy by dx to be this. So dx by dy will be the inverse of this. That's 2 of 5x minus 1 to the power of a half all over 5. So this is being multiplied by dy by dt. They say the y-coordinate is increasing at 5/8 per minute. So that's our dy by dt here. So that's times 5 over 8. And this should be equal to dx by dt, of which we have information here that dx by dt is 2. So for dx by dt, I'll put 2. So we now need to simplify this and solve for x. So right here, I'll divide 5 into 5. And I'll also divide 2 into 8. It goes there 4 times. So what I'm left with for now is 2 is equal to 5x minus 1 to the power of a half. And that's over 4. And now I'll multiply both sides by 4. And this will give me 5x minus 1 to the power of a half is equal to 8. And while I'm here, I'm going to square both sides. So squared here and squared here. So that's 64 is equal to 5x minus 1, because these 2's will cancel out. So 64 is equal to 5x minus 1. That's 5x is equal to 64 plus 1, which is 65. And dividing both sides by 5, I'll get the value of x coming out as 5 into 65, that's 13. So x is equal to 13. And this is the answer right here for part B. That's the x value, the value of x when the y-coordinate is increasing at 5/8 unit per minute. Let's scroll down to number 7. Number 7, part A. Show that tan theta over 1 plus cos theta plus tan theta over 1 minus cos theta is identical to 2 over sin theta cos theta. So to prove this identity, I'll select the left-hand side. And I'll find the common denominator, which is 1 plus cos theta bracket 1 minus cos theta. And I'll multiply this 2, so that's tan theta bracket 1 minus cos theta. And this 2 will give me plus tan theta bracket 1 plus cos theta. So I'll continue simplifying. Tan theta times 1, that's tan theta. And tan theta times minus cos theta is minus tan theta cos theta. And here I have plus tan theta times 1, that's tan theta. And tan theta times cos theta, that's tan theta cos theta. And it's all divided by the denominator. So right here, minus tan theta cos theta plus tan theta cos theta gives us 0. So we're left with tan theta plus tan theta, which gives us 2 tan theta. And it's all divided by the denominator, 1 plus cos theta, bracket 1 minus cos theta. Now, if you look at the denominator here, and if you think at the form of difference of two squares, how a squared minus b squared is equal to a plus b bracket a minus b, you can notice that this can be simplified to 2 tan theta over 1 squared, that's 1 minus cos theta squared, which is cos squared theta, which is equal to 2 tan theta, and here 1 minus cos squared theta, using the identity, is actually sine squared theta. Now 2 tan theta is like 2 of sine theta over cos theta. That's the identity for tan, and we're dividing it by sine squared theta. So we can say it's 2 sine theta divided by cos theta times 1 over sine squared theta. So here sine theta will divide into sine squared theta, and we get a single sine theta. So we'll now be having at the top 2, and at the bottom cos theta times sine theta is sine theta cos theta. So this becomes the result. Now if you look, this is actually what they want us to find, 2 over sine theta over cos theta, and that's what we have right here. So I can say hence shown. Let's scroll down to the next question, and that's part B. Hence solve the equation tan theta over 1 plus cos theta plus tan theta over 1 minus cos theta is equal to 6 over tan theta. Alright, now already we have the identity for this left hand side, and we obtained it as 2 over sine theta cos theta. So this should be equal to 6 over tan theta. Now we know from the identity that tan theta is equal to sine theta over cos theta. So when we have tan theta as at the bottom here, that's 1 over tan theta, should be equal to the reciprocal of this, so that would be cos theta over sine theta. So I can apply this here to say this is equal to 2 over sine theta cos theta is equal to, and for 6 over tan theta is the same as 6 cos theta over sine theta. And while I'm here, I'll multiply both sides by sine theta cos theta, so this side again by the same, which means here they'll cancel out, so I'm left with a 2, and here sine theta will cancel out with this, so I'm left with 6 cos theta cos theta, which is 6 cos squared theta. Okay, so I have 6 cos squared theta is equal to 2, and dividing both sides by 6, I have cos squared theta is equal to 2 over 6, which is a third. I can now square root both sides, and this will be equal to plus or minus 1 over root 3. So I'll have theta is equal to arc cos of 1 over root 3, and I'm going to use the calculator for this, and that comes out as 54.7 degrees. So 54.7, and if I look at the quadrants, Also taking into consideration that we want values of theta between 0 degrees and 180 degrees. So cos is positive in the first quadrant, which has values between 0 degrees and 90, and negative in the second quadrant, which is 180 minus theta, which has values between 90 and 180 degrees. So that's 180 minus 54.7. That's 125.3. So these are the two values. So theta has values 54.7 degrees and 125.3 degrees. These are the two solutions we have right here for the value of theta. Let us look at question number 8. The first term of a progression is sine squared theta, where theta ranges between 0 and a half pi. The second term of the progression is sine squared theta cos squared theta. So on A, given that the progression is geometric, find the sum to infinity. So here, the information we have is that the first term of the progression, that's U1, is sine squared theta. And we've also been told that the second term of the progression is sine squared theta cos squared theta. So U2 is sine squared theta cos squared theta. But now on A, they say that the progression is geometric. Now for a geometric progression, the first term is A. So that will be A is sine squared theta. And the second term, we can denote it as AR. So that is sine squared theta cos squared theta. Which means that we can actually find the common ratio R by dividing the second term by the first term, which in this case will be sine squared theta cos squared theta divided by sine squared theta. So here we can cancel out the sine squared theta and we get R coming out as cos squared theta. So now that we have the common ratio, we can now apply the formula for sum to infinity. So we know that the sum to infinity of a geometric progression can be worked out with the formula A over 1 minus R, which therefore means that the sum to infinity in this case will be A, which is sine squared theta, divided by 1 minus R, which is 1 minus cos squared theta. So this means that we'll be having sine squared theta divided by, and we can apply the identity to get 1 minus cos squared theta as sine squared theta. So if I divide the two, sine squared theta into sine squared theta, the result comes out as a 1. And this here becomes the answer. So the sum to infinity in this case comes out as 1. Let's scroll down to part B. It goes, it is now given instead that the progression is arithmetic. So on B part 1, find the common difference of the progression in terms of sine theta. So the key word here is that we now have an arithmetic progression. And we know that for an arithmetic progression, the first term can be denoted by A, and from the question, that's sine squared theta. And the second term, which is denoted by A plus D, is, according to the question, sine squared theta cos squared theta. So they say find the common difference of the progression in terms of sine theta. So to find the common difference, we subtract the second term, which is A plus D, minus the first term, which is sine squared theta. So that will be subtracting sine squared theta cos squared theta minus sine squared theta. So I'll apply the identity here for cos squared theta. So for cos squared theta, I'll have 1 minus sine squared theta. And that's minus sine squared theta here. Simplifying the bracket, I'll have sine squared theta multiply 1. So that's sine squared theta, and sine squared theta times minus sine squared theta. That's minus sine to the 4 of theta. And that's minus sine squared theta. And here, sine squared theta minus sine squared theta gives us 0. So we're left with minus sine to the power 4 of theta. And this is the answer right here. Let's go to part 2. Find the sum of the first 16 terms when theta is equal to a third pi. So here we're looking for the sum of terms of an AP. And what do we have? We have the first term, that's A, as sine squared theta. And we also have the common difference, that's D, which we obtained in part 1. So D in this case is minus sine to the power 4 of theta. So that's minus sine to the 4 of theta. Now, we're being taught in the question that theta now is a third pi. So that means that A will come out as sine squared of a third pi. This is the same as sine of a third pi all to the power of 2. Now, sine of a third pi is like sine of 60 degrees. And if you know already your common trig values, the sine of 60 degrees is root 3 over 2. Now you can even use a calculator for this. So that's like root 3 over 2 squared. So we know here that root 3 squared, that's 3, and 2 squared, that's 4. And for D, the common difference, we can see that the common difference D here is minus sine to the 4 of theta, which is the same to me as minus of sine squared theta squared. It's just the same. Okay, but you see how we had obtained in for A sine squared theta to be 3/4. So I can say that's like minus of 3/4 squared, which can give us minus of 3 squared, that's 9, and 4 squared, that's 16. So we now know what A is and what D is when theta is equal to a third pi. So for us now to find the sum of the first 16 terms, we can apply the formula for sum of terms for an AP. This in this case is going to give us 16 over 2, 2a, which is now 2 of 3/4, plus n minus 1, n is 16, so n minus 1 is 15, and d, which is minus 9 over 16. So this is what we now have. So we can just use the calculator for this. So let me do a quick working. And here I'm going to get minus 55.5. So the sum to 16 is minus 55.5. And that's the answer that we're getting here for part 2. And that's it for this question. Let's now scroll down to question number 9. Question 9. The function f and g are defined by f of x is equal to x squared minus 4x plus 3 for x is greater than c, where c is a constant, and g of x is equal to 1 over x plus 1 for x is greater than minus 1. So on A, express f of x in the form x minus a squared plus b. So here, what is required is for us to complete the square. We have f of x here as x squared minus 4x plus 3. And to complete the square, I'll use x squared minus 4x. So here I'll take x minus half coefficient of x, so that would be minus 2 squared, and that would be minus of minus 2 squared, and that's plus 3. So we will get x minus 2 squared minus 4 plus 3, and this gives us x minus 2 squared minus 1. So this here is the answer for part A, where A in this case is 2 and B is minus 1. Let's now scroll down to part B. It is given that f is a 1-to-1 function. State the smallest possible value of c. Now, you can notice that the domain is x is greater than c. And we know already that this is a quadratic curve, a parabola, and it's a parabola in such a way that it's a U-shaped parabola. And the domain is x is greater than c. It means that we are supposed to start from the minimum point of the parabola going to the right. So it means that all the part that is to the left is not relevant. The function is only defined for values of x that are greater than c. So all we need is to find the minimum point. We can deduce the minimum point from the completed square format of the function. So we obtain the function f of x in completed square form as x minus 2 squared minus 1. So we're saying since f of x is x minus 2 squared minus 1, then the minimum point is, we can deduce it from here, that will be minus of this number, so that's 2, and we take this number here to be the y coordinate. So this here is the minimum point of f of x, which therefore means that the domain is defined for values of x greater than c, where c is the minimum point or minimum x value. So x should be greater than the x value here, which is 2, and therefore the minimum value of c should come out as 2, and that's the answer here to part B. Let's scroll down to part C. It is now given that c is equal to 5. Find an expression for f inverse of x and state the domain of f inverse. So we have our f of x as x minus 2 squared minus 1. We can write that as y is equal to x minus 2 squared minus 1. And here I'm going to try to make x the subject. So I'll add 1 to both sides. So y plus 1 is equal to x minus 2 squared. And I'm going to square root both sides. So I'll square root here and square root here. This means that I'll be left with x minus 2 here. And here we'll be having plus or minus square root of y plus 1. So eventually we get x coming out as adding 2 to both sides. That will be 2 plus or minus square root of y plus 1. And then if we interchange variables, we're going to get y being equal to 2 plus or minus square root of x plus 1. So that means therefore that f inverse of x is going to be 2 plus or minus the square root of x plus 1. But now you need to understand something. From the question here, the function f of x is defined for the domain x is greater than c. So let me take this here because it's important. So this is the function right here. And on this part, they say it is now given that c is equal to 5. So it means that the domain is now x is greater than 5. Now, what you need to understand is that the domain of the function is comparable to the range of the inverse function. And what that means to us is that if the domain is x greater than 5, that the range of the function f inverse will be f inverse of x is greater than 5. So it means that the f inverse of x is defined when we have 2 plus square root of x plus 1. So this here is the inverse. Now for the domain of the inverse function, you need also to understand that the range of the function is comparable to the domain of the inverse, which is the one that we're looking for. Which means for us to find the domain of this inverse function, we have to know what the range of the original function is. Now we know for certain that the graph of the function f is a U-shaped parabola, and we have the minimum point at 2, -1. But now the domain is x is greater than 5, which means 5 can be a point somewhere around here. So because of this domain restriction, the other part of the graph is no longer defined. So the graph is only defined when x is greater than 5. And when x is equal to 5, what is the y value if we are going to look for it to get the domain? To get the y value here, we only have to substitute 5 into the original equation. So when we have f of x is equal to x squared minus 4x plus 3, that will be the y value is x squared, that's 5 squared minus 4 of 5 plus 3, that's 25 minus 20 plus 3, so we get 8, which means 8 is the minimum y value. So the range of the function is therefore y is greater than 8. So this range of the function is comparable to the domain of the inverse. So if the range of the function is y is greater than 8, then the domain of the inverse should come out in terms of x as x is also greater than 8. And this now is the inverse and domain of the inverse. And that's how we do it. Let us now scroll down to part D. Find an expression for g f of x and state the range of g of f. So here, this is a composite function, g of f of x. And we know from the question that the function g of x is defined for 1 over x plus 1. So let's take this. And put it here. So we have information that g of x is 1 over x plus 1. So when we have g of f of x, it means that f of x is an input into the function of g, which means that we can have 1 over x, which is the input. So that will be f of x plus 1. And f of x in completed square form, we got it as x minus 2 squared minus 1, and that will be plus 1. So we can simplify this to 1 over, and that's x minus 2 squared, and minus 1 plus 1 is 0. So g of f of x is 1 over x minus 2 all squared. Now for the range of g of f, we know that f of x is an input into the function of g. And we know that f of x has a range which we obtained on part C as the range of f is y is greater than 8. So we know here in this case that f of x is always going to be greater than 8. Now if f of x is greater than 8, and we know that g of f of x is equal to 1 over f of x plus 1, it means that we can actually find the range of g of f of x using the fact that f of x is going to be greater than 8. So I'm going to equate f of x to 8. So g of f of x here will come out as 1 over 8 plus 1, which is 1 over 9. So we know for certain that 1 over 9 is one of the limits of g of f of x. But let us now also consider what happens to g of f of x as f of x increases or approaches positive infinity. So as f of x increases, thus f of x is denoted by 8 here. As it increases, it means that the denominator here also increases, which means 1 over an increasing number here means that g of f of x will approach 0. Because if we divide 1 by an increasing number here, it means the whole thing, or g of f of x in this case, will approach 0. So we now have the limits here for g of f of x, which are 0 to 1 over 9. And that's the answer here to part D. Question number 10. The coordinates of 2 points A and B are -7, 3, and 5, 11, respectively. Show that the equation of the perpendicular bisector of AB is 3x plus 2y equal to 11. So here we've got 2 points, and the 2 points are A and B. And we want to find the equation of the perpendicular bisector, which is a line that divides the line into 2 equal parts. So this here is the perpendicular bisector. So for the equation of the perpendicular bisector, I'll first need to know the coordinates of the midpoint of A and B. So I'll start with midpoint of AB. And for that, I'll use the 2 points. So I'll have the sum of the x coordinates, which is -7 and 5. And I'll divide that by 2. Then the sum of the y coordinates, that's 3 and 11, and divide that by 2. So this is going to give me -7 plus 5 is -2, so that's over 2. And 3 plus 11 is 14, and that's divided by 2. So -2 over 2 is -1, and 14 over 2 is 7. So these are the coordinates of the midpoint. I'll also need the gradient of AB. And for the gradient of AB, I'll also use the 2 points. That's change in y over change in x. So for change in y, I'll subtract the y coordinates, 3 minus 11. And for change in x, I'll subtract the x coordinates. So that's -7 minus 5. 3 minus 11 is -8. And -7 minus 5 is -12. So the gradient of AB is 2/3. The gradient of AB means I can now find the gradient of the perpendicular bisector. And the gradient of the perpendicular bisector should be the negative reciprocal of the gradient of AB. Since they are perpendicular, they meet at right angles, so the product of their gradients should be -1. So here the gradient of the perpendicular bisector should be the negative reciprocal of 2/3. So that should be -3 over 2. So now that I have a point on the perpendicular bisector, which is -1 and 7, and the gradient of the perpendicular bisector, which is -3 over 2, I can now say for the equation of perpendicular bisector, I'll use y minus y1 is equal to m of x minus x1. So x1 and y1 are these points -1 and 7. So I'll be having y minus 7 is equal to m, that's the gradient, is -3 over 2 of x minus the x1, which in this case is -1. So it becomes +1 here. And from here, I'll multiply both sides by 2. So all the terms by 2, and by 2 here, this 2 and this 2 will cancel. So on the left side, I'll be having 2y minus 14 is equal to, and on the right side, -3 will multiply x to get -3x, and -3 will multiply 1 to get -3. So eventually, if I add 3x to both sides, I'll be having 3x here, and the 2y is there, so that's plus 2y. And I'll add 14 to both sides. So on the right side, we'll be having -3 plus 14, which is 11. So this here is the equation of the perpendicular bisector. let's go down to part B. A circle passes through A and B, and its center lies on the line 12x minus 5y is equal to 70. Find an equation of the circle. So here we've got a circle, and it's passing through the points A and B. So we have A and B here. So this is A and this is B. And from the previous question, we'd obtained the equation of the perpendicular bisector of AB to be 3x plus 2y is equal to 11. So that's 3x plus 2y is equal to 11. So that's the equation of the perpendicular bisector. And we know that the perpendicular bisector divides AB into two equal parts, and it should also pass through the center of the circle. We're also told that the center lies on the line 12x minus 5y is equal to 70, of which that is also where the perpendicular bisector passes. That's 3x plus 2y is equal to 11. So we can solve the two equations simultaneously to find the coordinates of the center here. So this is what I'm going to do. So I'll label this to be equation 1 and this to be equation 2. So equation 1 is 12x minus 5y is equal to 70. That's 1. And I'll use elimination. So I'll multiply the second equation by 4. So I'll go equation 2 multiplied by 4. And this is what we get. 4 times 3x, that's 12x. And 4 times 2y, that's 8y. And 4 times 11, that's 44. And this will give us another new equation, which I'm now calling equation 3. I've done this because I want to eliminate x. So we now have the x terms looking the same. So I can now subtract the two equations. Equation 1 minus equation 3. So 12x minus 12x is 0. Minus 5y minus 8y is minus 13y. And 70 minus 44, that's 26. So dividing both sides by minus 13, we get y coming out to be minus 13 into this, we get minus 2. So y is minus 2. Now I can take any one of the equations. Let's take the second equation. That's 3x plus 2y. But in place of y, I'm now putting minus 2. So that's equal to 11. So that's 3x minus 4 is equal to 11. So 3x is equal to 15 if I add 4 to both sides. And dividing both sides by 3, I get x coming out as 5. So therefore, the coordinates of center are coming out to be x coordinate, that's 5. And y coordinate, that's minus 2. So now that I have the coordinates of the center, I can now look for the radius of the circle. So for the radius, I'll use the coordinates of the center and also the coordinates of A. The coordinates of A have been given in the question that the coordinates of A are minus 7 and 3. So A has coordinates minus 7, 3, and the center, which I want to call C, is 5 and minus 2. So I can find the length of this line using the two coordinates. So I can go r squared, which is basically AC squared, is minus 7 minus 5, that's from the x coordinates, and squared, plus 3 minus minus 2, which is 3 plus 2 from the y coordinates, and that's squared. So it therefore means that r squared is equal to minus 7 minus 5, that's minus 12 squared, plus 3 plus 2 is 5, so that's 5 squared. So this will give us 144 plus 25. So r squared is equal to 144 plus 25 is 169. So we now know what r squared is, and therefore the equation of the circle should come out to be x minus the x coordinate of the center, that's 5, and squared, plus y minus the y coordinate of the center, that's minus 2. So it becomes plus 2 squared is equal to r squared, which is 169. So we now have the equation of the circle. And that's how we do it. Let's now move to the next question. Question 11. The diagram shows part of the curve with the equation y is equal to x cubed minus 2bx squared plus b squared x, and the line OA, where A is the maximum point on the curve. The x coordinate of A is small a, and the curve has a minimum point at B0, where A and B are positive constants. So on A, show that B is equal to 3a. So here, we have the equation of the curve as y is equal to x cubed minus 2b x squared plus b squared x. And we've been given information concerning the turning points. So we know that the curve has 2 turning points. That is when x is equal to a here, and also the turning point at b, which is a minimum with coordinates 0, b. So from here, I'm going to find the derivative of y with respect to x. So differentiating this, I get 3x squared minus, and differentiating minus 2b x squared. Note how minus 2b is a constant. So if we differentiate x squared here, we get 2x to the power of 1. And that's plus differentiating b squared x. That's a constant times x, so we just get the constant here. So dy by dx comes out to be 3x squared minus 2b times 2x, that's 4bx, and that's plus b squared. So right here, we're going to use the fact that at one of the turning points, x is equal to a. So we're saying x is equal to a, dy by dx will be equal to 0, because that's a turning point, and at the turning point, the derivative is going to be 0. So when x is equal to a, that's 3a squared minus 4ab plus b squared, and it has to be equal to 0 since it's a turning point. And from here now, I'm going to factorize this quadratic. So if I factorize, I'll split 3a squared into 3a and a. And I'll look for factors of b squared. In this case, I'll have b and b. And the best sign to use for both is when we have this being a minus ab and this being a minus 3ab to give us minus 4ab. So that can happen when we have a minus sign here and a minus sign here. So that's how we factorize it. So from here, I can now say either 3a minus b is equal to 0 or a minus b is equal to 0. Here we get b is equal to 3a if we add b to both sides, and here we get a is equal to b. But now, if you go back to the graph, I think you can see that there's no way that a can be equal to b, since a and b are distinct points. So we're not going to make use of a is equal to b, so therefore we can conclude that b is equal to 3a. And this is what is required for us to show. That said, show that b is equal to 3a, and we have thus done that. Now let's move on to part B. Show that the area of the shaded region between the line and the curve is ka to the power of 4, where k is a fraction to be found. Okay, so I'm going to take the graph here and put it where we can see it. So this here is the graph. So we want to find the area of the shaded region. And to find the area of the shaded region, I will first have to find the area under the curve. So I'm saying shaded region area is equal to area under the curve. That's from 0 to A minus area under the triangle. That's also from 0 to A. So we're going to start with area under the curve. Now for the curve, which has equation y is equal to x cubed minus 2bx squared plus b squared x. I'm going to write it in terms of A, since in the previous question we had proved that b is equal to 3a. So I'm going to write the equation of the curve in terms of A. So that will be, since b is equal to 3a, y should be, in place of b, I'll put 3a. So that's x cubed minus 2x squared of b, which is 3a, plus here we have 3a squared of x. I'll simplify it, so that will be y is equal to x cubed minus 6a x squared from here, and then that's plus 9a squared x. So this is the same equation, but I've only written it in terms of A. So now I can find the area under the curve by integration. So the area under the curve will be the integral from the lower limit, that's 0, to the upper limit, which is a of x cubed minus 6a x squared plus 9a squared x, and that's by dx. Let's do the integration. Integrating x cubed, we get x to the power 4 over 4, and integrating x squared minus 6ax squared, that's minus 6ax to the power of 3 over 3. And integrating this, I'll get 9a squared x squared all over 2, and that's from 0 to a. I'll continue simplifying. So I'll substitute a for x, so that will be a to the power of 4 over 4 minus, substituting a here, so it becomes 6a times a cubed, so it becomes 6a to the power of 4 over 3, and that's plus, and substituting a here, it becomes 9a, and a squared times a squared, that's a to the power of 4, that's all over 2. But if we substitute 0 for x into this whole thing, all we're going to get is 0. So eventually, for the area under the curve, we have a to the power of 4 over 4 minus, getting 3 into 6, that's 2, so that's minus 2a to the power of 4, and then that's plus 9a to the power of 4 over 2. So what I'll do here is I'll factor out the a to the power of 4, so I'll have the a to the power of 4 here. So factoring out, I'll be having a quarter here, and 8 to the power of 4 factored out, I have minus 2, and here 8 to the power of 4 factored out, I have plus 9 over 2. So I'll type this into my calculator. So that's a quarter minus 2 plus 9 over 2, and that's 11 over 4. So eventually we'll be having 11 over 4 of a to the power of 4. And this is the area under the curve. Now that we have the area under the curve, we now need to find the area under the triangle. So since we know that x is equal to a, we also need to find the y value here. Now I'll take the equation of the curve, which is this one here, which is in terms of a. So I'm gonna put it here, and we're gonna substitute x is equal to a here to get the value of y. So that will be y is equal to, since x is equal to a, y will come out as a cubed minus 6a of a squared plus 9a squared of a. I've just substituted x for a, so it becomes y is equal to a to the power of 3 minus 6. Here we get a to the power of 3 plus 9a to the power of 3. And I think you can see that we're actually coming out as y coming out as a cubed minus 6a cubed, that's minus 5a cubed, plus 9a cubed, it comes out as 4a cubed. So this means that we now know what the y coordinate of is, that's 4a cubed. So we can now work out the area of the triangle using half times the base times the height, which is 4a cubed. So for the area under the triangle, we're going to say it's half times the base, that's a, times the height, that's 4a cubed. So this will give us 2a to the power of 4. So this means that we can now work out the shaded area, and which is area under the curve minus area under the triangle. And we got the area under the curve as 11 over 4a to the 4. So that's equal to 11 over 4 of a to the 4 minus area under the triangle is 2a to the power of 4. So that's 11 over 4 minus 2. And this gives us 3/4. So we have 3/4 of a to the power of 4. And this here is the area of the shaded region. And that's how we do it. So that's the answer to the last question of the paper, and we're done.